Basic Darkroom Techniques. Part 2. Negative Evaluation and Contact Printing. In this program, we will evaluate black and white negatives and learn to make contact prints, frequently called proof sheets. The first thing you should do after the negatives are dry is cut them into strips of 5 or 6 frames for 35mm negatives and 3 or 4 frames for 120 roll film negatives. Then, after you have examined them and made contact prints, they can be placed in clear or frosted pages for safe storage and convenient selection later on. The number of frames on each strip will be dependent on the type of storage file used. Examine the negatives. Remember that in the developing process, silver grains that were exposed to light were turned into varying dark tones of metallic silver. Silver grains that were not exposed to light did not change physically in the developer and were made soluble by the fixer and were washed out of the film in the washing process. The image remaining is called a negative because all tones are reversed. Let's say you photographed your friend. She looks like this using color film, light-skinned with dark brown hair. A black and white negative of her looks like this. The light skin reflected much light, causing the face to show on the negative as dark metallic silver. The dark hair reflected less light and appears light on the negative. Clear areas like the hair allow more light to pass through than do dark areas, like the face. So the print is a reverse of the negative, with dark and light tones appearing as they should. If a negative receives too little light, it will look like this. It is underexposed. If a negative receives too much light, it will be dark like this. It is overexposed. A negative that is properly exposed from an average lighted scene will show both dark and light areas with a gradation of tones between. It will produce a nice print with blacks and whites and a gradation of tones. Sometimes, even with proper exposure, a negative will turn out differently than you expected, like this one, which is too light, or this negative, which is too dark. Remember the 3 processing controls: temperature, time, and agitation. They all influence the density of the finished negative. Density indicates the amount of silver deposit produced by exposure and development. This negative has little density. This one has much density. In addition to exposure, just how do the 3 processing controls of temperature, time, and agitation influence density? Higher than recommended temperatures, longer than recommended development times, and too much agitation all increase density. Lower than recommended temperatures, shorter than recommended development times, and no agitation all decrease density. Let's summarize how both exposure and development influence negative density. This negative lacks density due to underexposure. Aperture and shutter were set incorrectly, or possibly the ASA/ISO number for the film was set too high on the camera's meter. This negative is too dense due to overexposure. Aperture and shutter were set incorrectly, or possibly the ASA/ISO number of the film was set too low on the camera's meter. This negative is underdeveloped because development time was too short, solution temperatures too low, and/or too little agitation was given during film processing. This negative is overdeveloped because development time was too long, solution temperatures too high, and/or too much agitation was given. We hope none of your negatives look like this. No density at all. This could be caused by a shutter that didn't open, or film that wasn't drawn through the camera, or use of the wrong processing solution. We also hope none of them look like this, completely opaque. Possibly someone opened the back of the camera, exposing this part of the film, or it was exposed while loading into the developing tank. There are other problems to look for while evaluating the negatives. Scratches like this indicate dirt in the camera or film cassette. Irregular scratches indicate rough handling while loading or when the film was wet. White blotches and surface tears like these indicate careless storage. Blemishes like this are caused by light leaks through the felt trap of the cassette. Always load a camera away from the direct sun. A blemish like this is caused when film touches itself in the developing tank, a definite reason to carefully load film. Spots like these, called watermarks, are due to uneven drying. They are impossible to remove and result in marks on the final print. Be certain to use a wetting agent before hanging film to dry. You can examine your negatives using a small magnifier like this. A better way to choose the ones you want to enlarge is to make sheets of contact prints. These are often called contact sheets or proof sheets. It's easy to make contact prints. All you need is photographic paper, paper developing chemicals, and a few simple pieces of equipment. An orange safe light is not very bright, but it provides enough light so that you can see what you are doing, and paper exposed to it for short periods of time will not be affected. While working under a safe light, you will need a totally darkened room with no light leaks from the outside, which might expose the light-sensitive paper. The other equipment needed is a piece of glass or a contact printer, which is a piece of glass in a frame. A thin sheet of foam rubber the same size as the glass should be used under the photographic paper to ensure good contact with the negative. The glass holds the negatives flat against the photographic paper while it is exposed to white light. Be sure the glass is placed snugly on top of the negatives before exposure. To obtain optimum contact between the negatives and the paper, it may be necessary to apply pressure on the glass during the exposure. You will also need 3 trays to hold the processing solutions and a pair of tongs to move the paper between trays. The trays should be large enough for the paper you are using. The first tray holds the paper developer. It's a different developer than that used for film. It is sold in powdered form, which is then mixed with water for a stock solution. For a working solution, it is usually diluted 1 part developer to 2 parts water, 1 to 2. Dilute to a working solution just before use, as it oxidizes rapidly after dilution. Use an acetic acid water solution for the stop bath in the second tray. Dilute according to the directions on the acetic acid container. The fixer, the same kind used for film, is dissolved in water according to directions and used full strength. Pour it into the third tray. A fourth tray or tub of water can be used to hold contact sheets which are fixed and waiting to be washed. The room electric light or light from an enlarger can be used to expose the paper. In this illustration, the enlarger is used as the light source. Turn off the room light and turn on the orange safe light before you open the box of photographic paper. Like film, the photographic paper has an emulsion coating over a paper base rather than the cellulose acetate base of film. If the paper curls, the emulsion side is the concave side. The emulsion side of film is the dull side, or as with paper, the concave side. Place the negatives on the enlarging paper, emulsion side of film against emulsion side of the paper. Carefully put the glass on top of the negatives. It may be necessary to hold the glass firmly in place against the paper. If you are using the room light to expose the paper, turn it on for about 5 seconds. If you are using the enlarger light, set the lens at f8 and expose the paper for 8 seconds. Remove the glass and the negatives from the paper. Slip the paper into the developer with the emulsion side down. When the paper is fully immersed, turn it over with tongs. Agitate by gently rocking the tray. Development time for most papers is between 2 and 2½ minutes. If the print develops in less than 2 minutes, the exposure time was too long. If it takes longer than 2½ minutes, the exposure time was too short. With a little practice, you will be able to reduce paper waste to a minimum. Take the print out of the developer and let it drain into the developing solution. Then insert it in the stop bath and agitate for 15 seconds. Let it drain again. Insert it in the fixer and agitate. Papers normally fix in 2 to 10 minutes depending on the fixer and paper type. After fixing, the paper should be washed for 30 minutes. This time can be reduced by 1/2 if a hypo-clearing bath is used before the wash. Resin-coated papers require much less time for washing, about 2 minutes, because the base is non-absorbent and only the surface needs to be washed. Sponge off the excess water on both sides of the contact sheet. Resin-coated papers will air dry. They can remain on the table just as seen here until dry. After being sponged off, paper-based papers can be dried between blotters on an electric dryer such as the one shown here. Place the finished contact sheet with the negatives for a convenient reference when you start enlarging your negatives. The next program will teach you how to make a photographic enlargement.